Sweet. Okay, so you got the final review packet. The answers to the final review packet are posted online, or they will be posted online today, or on Canvas, I should say. They'll also be, we'll have them posted, we'll probably post them up in the room tomorrow for class. Okay? Okay? Like I said earlier, this topic is going to be on your test tomorrow, or not test tomorrow, test next week. Just remember that your test is 1 week from today. The final is going to be in this room at 7:50 if you're a migrating student in here next week, Thursday, and then later on in the day if you are a raw grader. I don't even remember what time. What time does period 3 start? 10:25? So 10:25 if you are a raw. Okay? 7:50 if you're me, 10:25 if you're raw in here, in this very room. Okay? You will get your note sheet, okay, on that final. You started it back when we were doing graphing rational functions. You can add anything to that you want. That is all that you get other than a calculator. Okay? It is, just looked yesterday now. I think it's 15. I think it's 15 short answer questions. Okay? So you should have plenty of time, but because it's short answer, it's not, they're not fast. Like there's work to be done in every single one of them. Okay? So I strongly recommend that you bring a calculator because then you're not relying on the limited amount that we have.
Calculate one question and multiple answers.
Like there's 15 total questions. It's not multiple choice.
No, I mean.
I know it's like one question and then broken up into 4 different parts. There's a few that are broken up, but it's only it'd be like 2 questions. Be like, for lack of a better term, solve this inequality, graph this inequality. You know what I mean? It'd be something like that, or find the intercepts and then graph the rational function, or kind of like what we were. Okay, it's not overly terrible. In the past, because we don't get to write this one. This is actually part of your NTC final, and so we don't get to write it. So the past few years they've been like, oh, it's actually not too bad afterwards. So, okay. All right. Any other final questions? I don't. Okay, we don't curve it. Yeah, that's the other thing. We don't curve it. Okay, there is no curve. Don't ask for one. Okay. All right, here we go. Inverse functions. Okay. So before we start, one little background piece. We got function notation. Remember that the name of a function is some letter and then the parentheses and the variable that is in that function. We read that f of x. Okay? Today what we're going to be finding is we're going to be finding the inverse function. And the inverse function written in function notation is the same name, the same variable, just with a -1 exponent on the name of the function. Remember that first letter is the name of the function. So we've got f of x and we've got the inverse of f. Okay? Okay? So then today, apparently I took that out. I thought I had something down below that. Okay? So that's what we're going to talk about today is inverse functions. Okay? So our first function that we are going to be dealing with is, we'll go with a linear function, f of x equals 4x plus 2. We want to find the inverse of that function. Okay? So the first step that we're going to do is we are going to take it out of function notation and we're going to replace the name of the function with what? They're the same. We could have written this as y equals 4x plus 2 and had it been, would have gotten us the same graph, the same picture, everything. The only difference is when it's written in function notation, the very first thing that we do is we write it in just normal y equals notation. Okay? So that's the first thing. Pretty easy on that. Second thing that we're going to do to find the inverse is we are going to switch the positions of x and y. Okay? So wherever there's a y, it now becomes x. Wherever there's an x, it now becomes y. Everything else stays the same. You just switch your x and your y. Okay? Then, what we do with that new equation is we solve that equation for y. It's not going to be in y equals form anymore because you switched the x and the y. So now we're going to solve this for y. So the first thing that I would do is I would subtract 2 from both sides. That gives me x minus 2 equals 4y. Then I would divide both sides by 4, and that gives me x over 2, or excuse me, x minus 2 over 4 equals 1. And then last but not least, we replace the y with the inverse of f. So this then would be the inverse of f is x minus 2 all over 4. I'll give you a moment here to make sure that you have those steps written down, because those would be good steps to put on your note sheet. One of those 4 is the inverse of f. Okay? So you might have a question that says, which one is the inverse? Well, one thing that you can do is you can find the inverse of f. So we could say here, y equals 3x to the 5th power minus 2. Then the first thing that we're going to do is switch x and y. So then that's going to be x equals 3y to the 5th power minus 2. Then what do we have to do? Got to solve for y, right? Okay, so we're going to add 2, you said, Phoenix? Okay, add 2. That's going to give me x plus 2 equals 3y to the 5th power. Next, divide both sides by 3. That's going to give me x plus 2 divided by 3 equals y to the 5th power. 5th root. Yep, we're going to take the 5th root of both sides. So this right here would be my inverse, right? The one on the far right, this one. So that one is my inverse. Good? Awesome sauce. Okay. Now, in higher level mathematics, in order to prove that two functions are inverses, we have to show the composition property of them. And the composition property says that if f of x and g of x are inverses, then f of g of x equals x, and the kicker is and g of f basically saying is you need to take this function and put it into that function. Then you need to take this function and put it into that function. And when you do all of your simplifications, you should just have x at the end. If you have anything else, they are not inverses. Okay? And you have to do both. You can't get away with doing just one. You've got to do both in order to mathematically prove that they are inverses. NTC has been classic, usually every couple of years, and they've mixed up their patterns. So I can't tell you if this is a year or not for it. They've always said, prove that these two are inverses. Like every few years, they throw in a question, prove that f of x and g of x are inverse functions. And you have to show that. Okay? So let's try one. Okay? Let's do this one. So there's f is in blue, g is in red. We need to show that they're in, or we need to verify, or we need to prove that they are inverses. So if they truly are, then this is the case. So I need to find f of x minus 1/2. So I need to put that into my blue function. So wherever there's an x, I put the entire g function in there. Then I simply do the math. Okay? 4 times 1/4. That's 1, right? Times x is just x. 4 times 1/2. 2. So this is minus 2. Excuse me. Then, keep the color scheme going. X minus 2 plus 2. Just x, right? That's good. That's what we needed it to be. We needed it to be x, right? So that part works. Then I've got to show that g of f of x is also just x. So I need to put the function f for x plus 2 into my g function. Again, 1/4 times 4. 1 times x is x. 1/4 times positive 2. 1/2. It's 2/4, which reduces to 1/2. X plus 1/2 minus 1/2. X. So because we showed both of those, now we have verified that they are truly inverses. Questions, comments, concerns, clarifications? Okay. You try one. You tell me if those functions are inverses. So I need to go f of 3 times 1/3 is 1, right? Times x is x. 3 times 1 is 3. 3 minus 1 is 2. I get x plus 2 there. Are they inverses? No, because what does that have to be? Just x, right? So these are not inverses. I don't have to go any further because they are not inverses. Okay. What's up, man?
Would it be possible to state that answer, like, because you said sometimes they don't have the food that it is. What if, is it possible to get that answer for the first one, but then have it not have that food?
I don't know. Like if it doesn't if f of g of x doesn't equal x, or g of f of x doesn't equal x, then they're not inverses, and you can stop. Now sometimes, yes, you might do this one, and it'll come out to be x, and then you go over to the next one, and it doesn't come out to be x. Then also not. It's very rare though, but I have seen it happen, where you do one of them and it works out, you do the other one and it doesn't work out. I think that's what you were saying. Okay. We can skip that one. We're good on that one. All right. So now we're gonna play a game. Function, not a function. What's up?
Is there any way they could both come out to be like x plus 2? Or would that not?
Yeah.
But that's still not.
But it's still not inverses because it's got to just be x. Yeah. Okay. So let's play a game. Function, not a function. You've actually played this game before. Okay. How can I tell if a function, a picture, a graph, if you will, of a function is a function or not? Vertical line test, right? Okay. So we're going to run the vertical line test, and that's going to tell us if what we're looking at, the function, and we can just do a quick sketch of anything if we need to. That's going to tell us what we're looking at, function, not a function. Okay. Right? Inverses. What do we do with inverses? To find an inverse earlier, it was step number 2. What do we do? We switch the x and the y, right? Okay. So if I'm going to switch a vertical line, what am I going to switch it to? A horizontal line. So there is something out there called the horizontal line test. Now this is probably brand spanking new for you. You've probably never even heard of the horizontal line test. And the horizontal line test says that if we run a horizontal line up and down now across our graph, if it only touches our graph at one point always, then the inverse of what we're looking at is a function. Okay? So vertical line test tells us if what we're looking at is or isn't a function. Horizontal line test tells me if the inverse of what I'm looking at is or isn't a function. Now you may be saying to yourself, go ahead. No, go ahead.
Well, I was going to ask you, like, so are you doing that horizontal line test after you transfer it into the inverse?
No, we're looking just at that first graph. You're looking at one, so you're looking at one graph. So like, let's say we graphed a line.
Yeah.
Okay? So if I graph a line, right there, okay? So I run a vertical line across it,
It works.
and it works, then that's a function. If I run a horizontal line up and down on it, and that works, then the inverse of that is a function. Yep, it's the same picture. Yep. Okay. Alright? Okay? Now, why are we giving you the horizontal line test? Because that, if both of those are true, if both of those work out, then we have, oops, I thought I had it on this page. Where did I go with my one-to-one? Oh, my Lanta. Well, I guess we'll just write it in then. So if both of them are true, or I shouldn't say true. True is a bad thing there. Let's not use true. If both of them work. No, work's a bad one. What do you want to say? If both are functions, yes. If both are functions, yes. Good job. Then the f of x, the original function, is said to be 1-to-1. This has been a test question for roughly 13 years. And the only reason that I know it's been a test question for 13 years is because I've only been teaching this class for 13 years. Okay? There is a question on your final that says, determine if this function is 1-to-1. If so, find the inverse. That means that the vertical line test passed and the horizontal line test passed. It means that the function is a function and the inverse is a function. Yep. Okay? So what we need to do is, here is our first function that we need to determine if it's 1-to-1. Y equals 2x squared. Okay? Right now, knowing what you know, sketch the graph for me. Okay? Just has to be a sketch. Okay? Should be enough time to sketch it. What shape is it? You can use the letter. U. The U. It's a parabola. Yep. It's a square, so it's a parabola. Does it open up or open down? Opens up. Okay? So as long as you got a parabola that opens up, I don't care what it looks like. Right? Okay? So here is the actual function. It's a U. Okay? Now we got to play the game. Function, not a function. Vertical line test is first. That's test number 1. Is what we're looking at a function?
Yeah.
Yes, the vertical line test passes. F of x is a function. Yes, it is. Okay? Is the inverse a function? Why not? Right there. So it is not a function. We'll use purpley because it touches twice. The inverse is not a function. So because this one was true and this one is false, it is not 1-to-1. Okay? So in terms of this problem, it first asked us to sketch the graph. You did that. Second question, is it a function? We answered it. Third question, is the inverse a function? No, it's not. So therefore, it's not 1-to-1. So we don't have to find the inverse. Then you find the inverse by changing f of x to y, switching x and y, solving for y, switching y back to f inverse of x. Yep. With me? All right, let's try one more. Or you guys try another one now. All right. X cubed minus 2. Let me ask you a question. What if we don't know what this one looks like? What if we don't know what this one looks like? What can we do? Plug in? We can plug in some points, right? Okay. All right. So, like, what points do you want to plug in? Oh, I thought I could write right over the top of that. Oh, my Lanta. Right over here. What do you want to put in? If we put in 1. 1 cubed is 1, minus 2 is negative 1. Okay? What's another good one to put in? 0. Right? 0 is going to be negative 2. Negative 1? No, just negative 1. Right? We're just plugging in x's. So when you give me two numbers, that's the actual point that it is. Right? Okay? So if we plug in negative 1, negative 1 cubed is?
1, negative 1.
Which one? Because you gave me both.
Negative 1.
Negative 1, right? Yep, negative 1. Minus 2 is negative 3. Okay, so it's going to be down there like that. Let's go out a little farther. Let's go to 2. 2 cubed. 8 minus 2.
6.
Negative 2 cubed. Negative 8 minus 2. Negative 10. So to me, it looks like it goes like this. Yeah? Okay. Which it does. Okay. Function, not a function. Function, vertical line test passes? I would concur. Well, I don't know, you tell me. Let's run that across, right? That part, but that's because I didn't zoom in enough, but it does, yep, that is actually, it's good there. So, yep. So that means it's 1-to-1, that means what? What does that mean? So it's 1-to-1, which means, what is the inverse? You tell me. What's the inverse? How do I find the inverse? Oh, we got to actually do that now. Oh, man. F of x equals x cubed minus 2. So we first switch that to y, right? Then, nope, switch x and y. Then we got to solve for y. How do we want to solve for y? Add 2. Okay. And then what do we do? Inverse of f. So the inverse of f is going to be the cube root of x plus 2.
So
What?
So doing the test on the graph.
Yep.
If it is 1-to-1, or if it's not 1-to-1, does that mean the function, like one of the things would get out the x? Like if you had to check.
Right. Yes.
Okay. So it's just another way to like check to see if you're actually.
Yep.
Or the one actually
Well,
gets
I shouldn't say that because we could still, if we go back here to this one, we can find the inverse.
But it's not actually.
but it's not an actual inverse. It would look like, the inverse would look like this.
Yeah, that's what I'm saying. Like how we checked it before and we didn't, like when we did the other one, we didn't get like just X by itself.
Yeah.
This is another way to realize that you're not going to get it.
Okay? One more. Try that one. This, by the way, is also a good review starting for what the different kinds of functions that we've had so far this year. Okay, so it's a V. Absolute values are V's. Opens up. Vertical line test. Pass or fail? Pass. So yes, this is a function. Horizontal line test. Fails. So is the function 1-to-1? Nope. So we don't have to find the inverse. Which is good because it's very hard to get that y out of the absolute value. Okay? Awesome sauce. So, again, at the beginning of class, I handed out to you a final review packet. The way that I have set up that final review packet is that is a sampling of some of the old final questions that have been on an NTC final before in years past. So we put them on there. And I put them on there with their verbiage. Okay? NTC has a different language that they use when they are writing out their questions. So I put it in there with their verbiage so you kind of get some of that. I also gave you explanations after each problem as to what their verbiage means, basically translating it into Linzmeyer-Roth speak. Okay? Right? So definitely you want to read every part of that. Don't just skim it and actually think, because there's some stuff in there that's good, that you should put on your note sheet. Okay?